In this video, I'll be looking at various different white balance targets and seeing how they compare when doing an in-camera white balance for infrared photography or video. I'll be looking at the results when using filters that pass both visible and infrared light together, also one filter that passes mostly just infrared, and one filter that passes just ultraviolet. I'll be looking at both reflectance-based targets, where you take the white balance using the light reflected from the target, and also semi-transparent incident-based targets, where you place the white balance target over the end of the lens and shoot towards the light to take the white balance reading. When looking at the comparison images, what I'm looking for is neutral grey clouds. So if I hue shift or channel swap the image, the clouds should remain neutral because the red, green and blue channels all have the same values for the clouds. So we'll start off with the Lee 101 filter. This filter passes visible and infrared light together. So these images were all white balanced in camera using the respective targets, and then a +98 hue shift has been applied in post. Looking first at a piece of white card, the white balance on the clouds is off, though it doesn't look too bad once the hue's been adjusted. When taking the white balance image, you have to adjust the exposure to avoid overexposing the target. Next, looking at the color checker. Again, the white balance on the clouds is off, though it doesn't look too bad once you've hue adjusted the image. With the hue adjustment, the image is more red than using white card, and using the grey patch on the color checker for the white balance image, no exposure adjustment was needed. Next, looking at the Labsphere Spectralon standard. Again, the image doesn't look too bad, but the clouds are not neutral. The white balance is almost identical to when I used the white card as the white balance target. With a white standard, as I used here, exposure adjustment is needed when you take the white balance image to avoid overexposing the target, but you could just use a grey target instead. The main issue is how small the standard is makes it difficult to make it large enough in the frame to cover the white balance sample area while avoiding shadow, for example, of the camera on the target. Next, looking at a PTFE disc and just photographing it normally in reflected light. This gives pretty much the same results as the Labsphere and white card. The white balance is not neutral on the clouds, but the resulting image is not too bad. It's better than the Labsphere in terms of having the target big enough in the frame while avoiding shadows, but not as good as an A4 sheet of card. Exposure adjustment was needed for the white balance photo to avoid overexposing the target. Now looking at the Expodisc V3 in reflected light. I asked Expodisc if you could use the Expodisc as a reflective target, and they said it has not been designed for that, so white balance results may not be accurate if used that way, but I wanted to test it anyway. With the hue adjustment applied, there is less red and more green than the PTFE disc reflected. I wouldn't say it is better or worse than PTFE used for reflective white balance readings, just different. Next, we'll look at the Expodisc V3 used properly. This is with it covering the lens and the camera pointed towards the light source. You use it like an incident light meter. I find this an inconvenience as I set up my framing for the image I wanted, then have to remove the camera from the tripod to take the white balance image, and then put the camera back on the tripod and adjust the framing again. But this is not an inherent problem with the Expodisc, it's more a problem with my way of working, and if I did want to use the Expodisc all the time, I just need to get used to making sure that I take the white balance image first before framing up the shot that I want. No or minimal exposure adjustment is needed when taking the white balance image with the Expodisc, which is nice. The Expodisc does come with an adapter to fit the disc onto the end of your lens, but it's much simpler to just hold the Expodisc over the end of the lens manually. The resulting image isn't that great though. With the hue shift applied, the blue tint is fairly strong and red is quite weak. Quite possibly the white balance is technically correct, but I prefer a white balance that gives neutral clouds. I wanted to see if using PTFE over the lens would work in the same way that the Expodisc is used. Indeed it does, and it gives us a similar result. As with the Expodisc, using 3.5mm thick PTFE means no or only a very minor adjustment in exposure is needed when taking the white balance image to make sure that it's exposed correctly. Looking at the Expodisc V3 covering the lens with the camera pointed towards the subject, which is not how you're meant to use it, then this gives a bad result. As you can see, with the hue shift applied, red is very weak and the green is quite strong. Exposure adjustment is needed when taking the white balance image, because otherwise the exposure will be too dark. I also tested the PTFE over the lens and with the lens pointed towards the subject. This gives a bad result, very similar to what we got with the Expodisc when it was pointed in the wrong direction. Using an expanded PTFE target gives much the same result as standard PTFE. This has the same issue of needing to adjust the exposure to avoid overexposing the target for the white balance image. Using ePTFE over the lens like the Expodisc does not work as well as standard PTFE, and we get an image with less red after hue adjustment is applied. Next, looking at ePTFE disc covering the lens with the camera pointed the wrong way, as that is towards the subject. This required a large amount of exposure compensation to get the white balance image exposed reasonably, and like you'd expect based on the results of the previous tests, the resulting white balance is not very good. Next, looking at the Expodisc V2 covering the lens and with the camera pointed towards the light like you meant to use it. The Expodisc V2 was only designed for visible light. The resulting image, once hue adjusted, has less red than the Expodisc V3, so the V3 of the Expodisc does seem a bit better for infrared, but not a massive difference here. Now looking at 0.1mm thick PTFE sheet covering the lens with the camera pointed towards the light. When taking the white balance image, the sun can be clearly seen and a lot of exposure adjustment is needed to avoid overexposing the white balance image. The resulting image, once hue adjusted, does not have enough green, making for a magenta shift. Now looking at slightly thicker 0.25mm PTFE sheet covering the lens with the camera pointed towards the light for the white balance image. A better result, but the problems in taking the white balance image are much the same as using 0.1mm thick PTFE over the lens. And now a 0.3mm PTFE sheet covering the lens, again with camera pointed towards the light, basically the same as the 0.25mm PTFE sheet, which is not a surprise. Due to the cloud coverage on this day, I had to use a longer lens to take the white balance photo to white balance on the clouds. I'm not sure why, but the resulting white balance is not very good, and the image has a strong red tint once the image has been hue adjusted. In all my previous tests, doing the white balance on clouds has actually given me the best result, in terms of getting an image where the clouds are neutral in colour at least. All the other results in this test were pretty much consistent with what I saw in previous tests, so I'm not sure why I've got such a different result with the clouds here. Having to swap lenses, which meant also swapping over the filter used just to take a white balance image, is very inconvenient, hence why I generally prefer a white balance preset image. Using the colour picker to set the white balance on clouds in post gives the best result in my opinion, which is not really a surprise. Next, looking at the Zomei 720nm filter. This filter passes a very small amount of visible light and it's mainly just infrared. So using a sheet of white card, it seems spot on. With the colour checker, we get a slightly blue tint, but it's pretty good. The Labsphere standard seems spot on. PTFE disc reflected gives an ever so slightly warm image, but the exposure is darker in this image as well, so that may just be down to a change in the light. PTFE disc covering the lens and the camera pointed towards the subject. As we saw previously, white balancing with a diffuser over the lens and pointing the lens towards the subject does not work well, and the image here is too warm. PTFE disc covering the lens and the camera pointed towards the light. Interestingly, while not as overly warm as when pointing towards the subject, we're still getting a relatively poor result that is too warm. The ePTFE disc in reflected light is giving a good neutral result. ePTFE disc covering the lens with the camera pointed towards the subject is too warm and overly red. ePTFE disc covering the lens with the camera pointed towards the light source for the white balance image. This is slightly worse than the standard PTFE when used in the same way. The result is better than pointing towards the subject, but still not very good. Expodisc V2 covering the lens with the camera pointed towards the light. very similar to standard PTFE over the lens and shot towards the light. The resulting image is a bit too warm. Expodisc V3 in reflected light, not too bad, but their resulting image has too much red. Expodisc V3 covering the lens with the camera pointed towards the light, so that's using it correctly. Again, it's too warm with too much red. Expodisc V3 covering the lens with the camera pointed towards the subject, so that's using it incorrectly. As we saw before, pointing the lens towards the subject gives a worse result with an even warmer and redder image. Using a 0.1mm thick PTFE sheet covering the lens with the camera pointed towards the light, this is actually giving a better result than the Expodisc, but it's still slightly lacking in blue for a neutral result on the clouds. 0.25mm thick PTFE covering the lens with the camera pointed towards the light, and 0.3mm thick PTFE sheet covering the lens with the camera pointed to light are both pretty much the same as the 0.1mm thick sheet. Next, looking at clouds, where again the white balance image of the clouds had to be taken with a zoom lens, not the same lens that the actual photo was taken with. Again, white balance is way off, so I'm not really sure what happened here when in previous results I had found clouds to be the best. The clouds image was taken zoomed in to clouds near the bush on the right, so it's not like the clouds were in a completely different area to the image, so I'm not sure why I'm not getting a good result from that. Lastly, setting the white balance using a colour picker on the clouds in post gives the best result, as you would expect. Next, we'll look at the Candy Chrome filter. This is a GRB3 1mm thick and a Li 139 gel combined. This gives an image made up of both visible and infrared light, but you don't need to apply any hue shifts or anything on top for the desired effect. Using a sheet of white A4 card, the white balance result is not too bad, but it is slightly green. The colour checker gives a pretty decent result. Labsphere standard is a bit too green. PTFE disc reflected is slightly more green than the Labsphere and less red. PTFE disc covering the lens with the camera pointed towards the subject gives a bad result, as we'd expect, very green and lacking in red. PTFE disc covering the lens with the camera pointed towards the light. This is not quite as green biased as with the lens pointed towards the subject, but still very green tinted. ePTFE disc reflected, pretty much the same as the PTFE reflected, too much green and not enough red. ePTFE disc covering the lens with the camera pointed towards the subject gives a bad result, as we've come to expect. The ePTFE disc covering the lens with the camera pointed towards the light, slightly better than pointing towards the subject, but still pretty poor. Expodisc V2 covering the lens with the camera pointed towards the light, slightly greener than PTFE used over the lens. Expodisc V3 reflected is slightly worse, more green than the reflected PTFE, but very similar. Expodisc V3 covering the lens with the camera pointed towards the light is too green, not enough red, and it's actually worse than using it as a reflected target. The Expodisc V3 covering the lens with the camera pointed towards the subject is a bit worse than when used pointed towards the light, but not a big difference here. 0.1mm sheet of PTFE covering the lens with the camera pointed towards the light, and the 0.25mm thick sheet, and the 0.3mm thick sheet. They're all pretty much the same, too green and not enough red. Using the clouds, again having to use a different lens to take the white balance image of the clouds so I could zoom in on them, fill the frame with them. This is actually not green enough, it's slightly too magenta, though as a straight out of camera image I actually like this one the most, because the sky's more blue cyan than it is green. And white balancing on the clouds in post is correct, as you would expect. Now, in my original set of tests that I did quite some time back, I was using the Canon RF 28mm lens, and I found all my images came out with a very poor white balance, except the one that was white balanced on the clouds. And after looking at the images in more detail, I worked out why. It's because the RF 28mm lens has a large diffuse IR hotspot, so the colour temperature in the centre of the image is quite different to that at the edges of the image. and the clouds image that I used to white balance was taken with a different lens, so that did not have an IR hotspot, hence why it gave a much better result sort of overall for the image, rather than it being corrected just in the center and then the rest of the image being out. So I thought I would retest this lens with just a few of the white balance target options to show the differences. These images have not been corrected for the IR hotspot, but a 67° hue shift has been applied. So starting with the color checker, this looks pretty decent actually, much better than what I got in my original test. Technically it's too blue after the hue shift's been applied. PTFE disc reflected is blue with not enough red. Expodisc V3 covering the lens with the camera pointed towards the light is even worse. The clouds image taken with a different lens again, this is pretty good with a slight magenta tint near the centre and a yellow tint towards the edges thanks to the IR hotspot. Doing a white balance picker on the clouds in post gives pretty much the same result as the in-camera option. By choosing where we take the white balance sample from, we can get an image that is corrected fairly evenly. Next, looking at ultraviolet. For ultraviolet, I'm not concerned with neutral clouds. If you're doing ultraviolet landscape photography, you'll typically get a blown out white sky anyway, so there's not really any clouds to worry about. Instead, what I'm looking for is neutral PTFE, as this is the generally accepted standard for false colour ultraviolet images. For this test, I photographed my UV colour checker. The main part of it should be blue, the top row of holes should be neutral, the central row should be yellow, and the standard at the bottom right hand corner of it should be neutral as well. This was lit using an AD200 flash with the Fresnel removed at half power for the actual photos. For the white balance target images, the flash power was varied to avoid overexposing the targets, and the flash was moved where necessary to ensure that it lit the white balance target. For incident white balance targets, the camera was held just above the UV colour checker, facing the flash. Spectralon gives a good result, as I'd expect. The flash power had to be reduced to 1/8 power for the white balance setting image, but that's just because I'm using a white Spectralon target in this instance. Normally I would use a grey one where no changes to exposure are needed. Looking at a 0.3mm PTFE sheet laid on top of acrylic, so this is a reflected white balance reading. This gives a good result and no adjustment to the flash power was required. With the colour checker, I used the white card on it. No change to the flash power was required, but you can see that the result is not very good and the image has a yellow tint. With the Expodisc V2, this is not an image of the UV colour checker, but rather the Expodisc V2 target white balance image. As you can see, it seems to block UV, resulting in a black image that can't be used for setting white balance. The Expodisc V3 claims it works for 300nm to 2200nm, but as you can see there is a bit of a yellow tint. To be fair, they don't make any claims about perfect UV white balance, and I think the given range is more the transmission range of it, rather than what it's corrected for to provide correct white balance results for. No adjustment to the flash power was needed for the white balance image. Using a 0.3mm thick PTFE sheet over the lens, the flash power had to be reduced to 1/8 to get a properly exposed white balance image, and the results are actually quite good, which surprised me. With a 0.1mm thick PTFE sheet over the lens, the flash power had to be reduced to 1/16 power for the white balance image. Again, good results, but using an incident white balance reading with the camera where you have to move the camera to point it towards the light source is quite inconvenient compared to a reflectance-based white balance target. 0.25mm thick PTFE sheet over the lens, the flash power had to be reduced to 1/8 for the white balance image, and the results are in line with the previous two images. PTFE disc in reflected light, the flash power was reduced to 1/8 power for the white balance image to avoid overexposing the target, and we get a good result as we'd expect. ePTFE disc in reflected light, flash power was reduced to 1/8 power again for the white balance image, and the resulting image is much the same as we got with standard PTFE. So in conclusion, first I should emphasise that what I'm looking for in infrared photos and videos is neutral clouds, which may not technically be the correct white balance. From having to carry out these tests multiple times, I learnt that white balancing in camera can be quite variable. In previous tests, white balancing on the clouds was superior, while in my latest tests it didn't always give such good results. For IR and particularly images that combine infrared plus visible light together, I would probably say that white balance on the clouds is pretty good, providing you have enough cloud coverage in the sky to fill the centre of the frame with clouds. They need to be quite thick clouds, not thin wispy clouds too. Next to that, I would say that 3mm thick PTFE is a good choice. As a reflective target it works fairly well, and you can even use it as an incident target if you want. Using a previously created white balance preset based on clouds works well if the lighting is the same as when you took your white balance preset image. The Expodisc V3 is best as an incident target for infrared, but the cost is much more than a disc of PTFE, and PTFE is better for UV photography and videography. The main disadvantage of using a 3mm thick disc of PTFE is that it's quite annoying having to adjust your exposure for your white balance image to ensure that you don't overexpose the target, and then you have to adjust your exposure back to what it should be once you've done your white balance image and you're ready to take the actual photo. If using a lens that has an infrared hotspot, then you're best taking your custom white balance using a different lens that has no hotspot, as otherwise the hotspot can throw off the white balance reading. So I would say that an approximately 3mm thick piece of PTFE is the best overall solution. It may not give perfect results, but they're close enough.